Good afternoon, everyone. This is Dr. Pamela Gay. Can you hear me, Phil?
Yes, I can.
Okay. I am here with Phil Plait, the Bad Astronomer, and this is CosmoQuest's weekly science hour. This week we are going to help you get prepared for the upcoming Venus transit and tell you where you can look up, depending on where you are on the planet, how to look up safely, and why everyone is making such a big deal about a small speck of black on the sun. Now, this is an event that's hosted by CosmoQuest, and I have to give props to Emily Lakdawalla, my co-host. She and I alternate weeks, and she will be here next week, probably with Dan Durda of NASA, so stay tuned for much awesomeness next week. But
Dan
for now...
Durda.
He's someone you know. He's in your neck of the woods.
He and I went to college together. So, yeah, I've known him for 25 years.
So stay tuned next week, but you can go off and do other things between now and then. So for now, let's get started. Why do we care? Let's start with that.
You want me to tell them or you?
Yeah. No, go for it, Phil.
Well, let's talk about, just for a sec, what this is. The Venus transit, well, a transit in general, is when one object in the sky passes directly in front of some other object. You can think of it like an eclipse. The moon passes in front of the sun, we get a solar eclipse. That's a transit. Now, typically an eclipse is when most or all of the object is blocked. So the moon and the sun are about the same size in the sky. One passes in front of the other. You get the whole sun blocked, and that's why you get an eclipse. A transit is usually something small passing in front of something bigger. Now, in this case, Venus, which is about the size of the Earth, is going to pass in front of the sun in the sky. And the sun is much, much, much larger. It's over 100 times bigger. Now, because of the distances, the sun is far away and Venus is closer. The sun is going to be about 30 times the size of Venus. So the sun will be, yay big through a telescope, and Venus will be like that. This doesn't happen very often, and the geometry is really messed up. So it happens in pairs separated by 8 years, and then you have to wait 100 years before that happens again. So the last one was in 2004. The one before that was in 1882. The next one is in 2117. So if you plan on living to be 150, awesome, but if you don't, you're going to want to see this on Tuesday and Wednesday because it'll probably be your last chance.
Now, a lot of people are curious, why doesn't this happen every single year? And I've actually stolen the graphic from your website, which I'm going to bring up.
That's okay, I stole it too from somebody else. But I linked them and credit them. Ooh,
well,
we have Pamela and Pamela.
I just accidentally went recursive. Hold on just a second.
Star Striders.
Let's try desktop.
Okay, this would be the sky. There we go.
Okay.
Yeah, this is a graphic from, let me give the credit for it, IPS Radio and Space Services, if I'm not mistaken, from Australia. And it explains why we don't have one of these every time. And it's the same reason we don't have a solar or lunar eclipse every time the moon goes around the Earth. It's because Venus's orbit is tilted with respect to the Earth's. So we kind of measure everything from the Earth. So the Earth goes around the sun in an ellipse. It's essentially a circle. It's close enough to being a circle, but it's flat. If you see it from the edge on, it looks like a line. Well, Venus also orbits the sun in a circle. Its orbit is more circular than Earth's, but it's not coplanar. I love that phrase. It's not in the same plane as the Earth's orbit. It's tilted a little bit. You can kind of think of it as two hula hoops. You put one inside the other and then tilt one a little bit. And Venus's orbit is tilted by a little more than 3 degrees from the Earth. That's not very much. That's actually pretty close. But it's enough to prevent it from passing directly in front of the sun every orbit. Now, if Venus's orbit were exactly aligned with the Earth's, then we would see a transit every single time the sun, Venus, and Earth lined up. But because Venus's orbit is tilted, we don't. And so the only time you can get it to actually have a transit is when the Earth and Venus and the sun are at a special place. Well, I should say, when Venus and the Earth are in a special place in their orbits, things line up just right. And it turns out that only happens roughly every 100 years. The mechanics of this is bizarre. I like to think of it as hands on a clock. When the big hand and the little hand you start them at, say, noon, and they're both lined up. Then you wait a little bit more than an hour before they line up again, and then at like 1:05 or something like that. Then you have to wait a little bit longer than an hour, so they line up at 2:10 and at 3:15 and that. It's the same sort of thing with Venus and Earth. Even though Venus only takes 200 and something days to go around the sun, we don't line up with it except every 500 and something days, 584 days, I believe it is. But then you don't get a transit every time. You have to have the alignment right. And so you get all these crazy orbital, what are called resonances. And the way it works out is you get these pairs of transits 8 years apart, and then you have to wait 100 and, in this case, 105 years. And then after that, you get a transit in 2117, another one in 2115, and then you have to wait 100, I think, 20-something years before the next one, and then the cycle repeats. It's crazy, but that's the way it works.
And what's kind of awesome about this is, well, it sounds all crazy and complicated. It's actually the exact same physics that is why we don't have a solar eclipse every month, why we don't have a lunar eclipse every month. The entire solar system is made of tilted disks, and each one has their own set of resonances, and because Mercury is closer to the sun, we see it transiting more often. I've managed to actually see Mercury transit. I've never succeeded in seeing Venus transiting. But it's a matter of we just have to wait for the right alignments. Right. Now, it's a problematic eclipse in some ways, not eclipse, it's a problematic transit in some ways, because you have to be in just the right place on the planet.
That's right. Unlike a lunar eclipse where the moon just has to be up and you can see it, well, you know what, let me take a step back. That's not correct. And I'll just start over. Let me make this easier. I like to use analogies, and sometimes analogies make things worse. But think about what this is. This is Venus passing in front of the sun. This event is going to last for 7 hours, and if those 7 hours happen to be when the sun is not up in your sky, you won't see it. So if it's nighttime during those 7 hours, you don't see the transit. Now this map was made by Fred Espenak, who is Mr. Eclipse. If you go to eclipse.gsfc.nasa.gov, just look up Mr. Eclipse, you'll find it. And this is a great map because it has the whole Earth laid out in front of you. Where you see the dark gray, you do not see the transit. So if you are in southern or eastern South America, or basically western and southern Africa, you're not going to see this transit. Unfortunately, it all happens while it's nighttime for you. Now, if you start moving west, so that you're up in Central America and the United States, the continental United States, the transit occurs, it starts in the daytime, and then the sun will set while the transit is happening. So for me in Colorado, you can see, I'm in the sort of left third of the United States, the western third. I'll get to see the transit for a couple of hours, and then the sun is going to set while Venus is still in front of the sun. Then if you keep moving to the west or to the left on this map, and you see Alaska, for example, then you cross over to the other side, and you look over on Russia and, let's see, Indonesia, Eastern Australia, Japan, China. You get to see the whole thing. The sun will rise, the transit will start, the transit will end, and then the sun will set, and you get to see the whole thing. And then, finally, that last gray area, the one on the right that has, Eastern Africa, Europe, Saudi Arabia, India, and all of Western Asia, you will see the eclipse starting at sunrise. So if you want to get up early, you can go out and do that. If any of our listeners, watchers live in that area, then it's going to be an early Wednesday morning event for you. So this whole thing takes place on Tuesday and Wednesday, June 5th and 6th, from, help me out here, 1800 UT?
I will actually bring that map up in just a second.
Okay.
There we go.
I'm thinking East Coast time. I've had to convert this so many times to so many different time zones, I'm suddenly blanking out. There we go. So first contact, there are 4 different contacts, basically. When Venus when the edge of Venus just overlaps the edge of the sun, like this, and then when it's all the way in. Oh, here you go. So that's first contact. Second contact is when Venus is all the way in. Third contact is when it's on the other side of the sun and the edge just touches the sun. And fourth contact is when it leaves the sun. So the whole thing is 7 hours long. The difference between first contact and second contact is actually just a few minutes because Venus isn't terribly big. So it's only half an hour according to this list here. Third contact is then 7 hours later. And then 18 minutes later, it looks like, something like that, it's all over. So let's see, that's 2,200 UT, subtract 4 for East Coast. So if you're listening on the East Coast of the United States, this starts at 6 p.m. on Tuesday, June 5th. And if you think about that, if it starts at 6 p.m. and lasts for 7 hours... You
don't get a lot of it.
Yeah. And if you're on the other side of the Earth, on the other side of the date line, it's going to start Wednesday morning for you guys. So there you go. There's the timing of it. You can. I've had a couple of people say, what time is it going to happen for me? Go online and say, what time is it UTC, which is Universal Coordinated Time in French, I think. You can say, what time is it? You go ahead, Pamela. And
we will be posting on cosmoquest.org either late tonight or early tomorrow morning, depending on your time zone and my ability to write. All of the different times, when to check in, when our coverage is going to start, how to share pictures with us, because the one thing you and I, along with the great Fraser Cain and the bald astronomer Scott Lewis are going to be doing is live coverage of this event.
Yeah, we're going to be covering, I guess, all 7 hours. I sent a note to Fraser today asking when he plans on starting. At a guess, I would say we'll probably start an hour or so before the event, maybe a little bit less. And then we're going to have telescopes all over the world, I'm hoping. Yeah, that's the current plan. Okay, great. And that way we'll have coverage of this entire event. So even if you can't see it where you are, you can watch it online on CosmoQuest or on Fraser Cain's G Plus account. Today, yeah. And I'll be embedding it on my blog as well, on the Bad Astronomy blog. Now, I do want to point out the timing that is listed on this particular graphic that Pamela is showing are sort of, is that for a specific place? This is the generic. Coordinates. Probably so it's the geocentric coordinates. So if you were in the very center of the planet, this is what you would experience. So exact realities may vary with latitude. Yes, and more importantly, longitude. If you're on one side of the Earth versus the other, you're seeing Venus at a slightly different angle than you're seeing it if you're on the other side of the Earth. That's called parallax. That's the same thing as like when you put your thumb in front of your eye and blink your eye back and forth. I can, it's on one side of my webcam, it's on the other. It's the same thing. We're looking at Venus at two different angles if you're on two different sides of the Earth. And we'll get to that. I'll get to that in a sec because that's important. And so that changes the timing of the exact transit, your latitude and longitude. So on my blog, Bad Astronomy, if you go to Bad Astronomy, you'll find my blog. I've written up a tremendous number of links. I was just going to write up, oh, everybody's written about the Venus transit, just go here and here. And then I looked through my email, and I had about 10 or 11 live webcam coverage. Here's information on this and that. And I said, you know what? I'll just write it. So I wrote up a huge blog post, and I actually have a link that will take you to a place where you can put in a city nearby or your latitude and longitude, and it'll tell you where or what timing the eclipse will happen. It'll even put up little clocks. It'll put up a little disk of the sun and the path Venus will take. It's totally awesome. There's even an iPhone app that will allow you to see what the transit's going to be like for you. So I actually have been having a lot of fun with the iPhone app. Yeah, I played with it. I tried. It's got a practice thing. Yeah. So basically, what they want to do is, we'll get to this in a second. But if you're looking at this through a telescope, you'll see the disk of the sun, and you'll see Venus very clearly moving across it. And timing exactly when Venus has second contact and third contact is really important. And we'll talk about why in a second. And it turns out timing those is a little bit tougher than you might think. The Earth's atmosphere is boiling and roiling around, and that distorts the edge of the sun. Venus has an atmosphere, and there are optical effects called the black drop, which makes it look like Venus and the sun are connected even when they're not. And it turns out it's really hard to get the exact time. So they have a simulation of this on the app, and I was playing with it, and I was not doing too well, actually. I was off by, at one point I was off by 30 flipping seconds.
Oh, no.
Which is a lot.
Yeah.
So are you trying to find...
Yeah, I'm looking to get a black drop effect image. I think I just found a good one.
Oh, it's on my... I've got a picture of it on my blog, I think. There you go. That's a good one. That's a classic one, actually.
Yeah.
Is it? I can... Of course, my picture's not very big. But it's almost as if the Sun and Venus are connected, and they're connected by some black goo, so that when Venus pulls out, there's like a little bridge between them. It's just an optical effect. It has to do with the way light bends around inside of a telescope and all that, and it makes timing, the exact timing, very difficult.
And one of the things here, I'm zooming in on the image. One of the things that I love about this is this actually was part of what taught us that Venus has this crazy atmosphere, because the atmosphere gives Venus a fuzziness that when you combine it with the fuzziness introduced with our atmosphere, is just way more fuzziness than you want when you're trying to do precise science.
And also, I can't remember which transit it was, but somebody noted that there was a ring of light around Venus as it entered the Sun. And they said that's really only possible if there's an atmosphere bending the light. Kind of like when you put a spoon in a glass and it looks like the spoon is bent. Same thing. It's called refraction. It's bending of light. And so as the light's coming from the Sun, it bends around Venus's atmosphere, and it lights it up in a little ring, which is pretty cool, really. And that's kind of amazing to think that you can detect the atmosphere on another planet just because of the effect it has. You don't see it directly, but you see it indirectly because of the effect it has on the light coming from the Sun. That's pretty cool.
Now, one of the things that amazes me about this is all the things people do wrong. So beyond the fact that you do have people who don't understand you can't see this if it's nighttime because it requires the sun. That's the one that always leaves me the most baffled. No, the sun has set, you cannot see this. But then you also have people who are like, can I just look at the sun? No, please do not just look at the sun. And we're hoping that a lot of you got practice in with the solar eclipse, which had similar regions of the world in which it was visible. We're hoping you got practice safely looking at the sun, and we'd encourage you to use the exact same techniques that you used then. And I'm actually going to pull up the sun funnel that we were talking about earlier.
Oh, right.
During the solar eclipse, because this is one of my favorite things, and you can find all of the instructions for it at transitofvenus.nl, or just Google build a sun funnel and it'll come up.
Right. Unfortunately, the difference between this and an eclipse is that the eclipse is a big honking event. The moon is blocking a lot of the sun. So using a pinhole camera or using sort of indirect techniques to see the sun work pretty well. But in this case, Venus is a little tiny dot, and it may be more difficult to see using projection effects, but you can try it. This is to hook up to a telescope, isn't it?
Right. So for the sun funnel, what you need is a funnel you're willing to destroy, some paper just to measure things out, and a piece of cloth. A piece of old t-shirt works just fine. Once you have all of these pieces, the idea is you cut the funnel up, and then you actually end up attaching it to an eyepiece. Now, the reason that you do this is you don't want to look through the eyepiece, and having a giant funnel on it will hopefully remind you don't look through the eyepiece. And then you use this to project onto a piece of cloth about 10 inches away. And in the end, you end up with this really nice, large, crisp image of the sun, and absolutely no way to accidentally look through the telescope and cause harm to yourself. So this is one of those nice, safe, easy ways to project the sun. But it does require you to have a telescope that preferably has glass optics. There have been reports of people actually melting Galileo scope lenses doing this. All because you could use the telescope you have during the solar eclipse doesn't mean you can use it during the Venus transit. Solar eclipse, couple of hours. Venus transit, many hours. And that has an effect. So be kind to your plastic optics.
And also, Venus is only blocking 0.1% of the sun's disk, whereas the moon was blocking a large fraction. Once you go half the sun is blocked, you're getting half the amount of heat basically coming in from the sun in your telescope. You know, the purpose of binoculars, the purpose of a telescope, is to gather light like a bucket gathers rain, and then it focuses it into a smaller thing that goes into your eyeball or an eyepiece or something like that. So if I have a 6-inch telescope, it's an 8-inch telescope, sorry. If I have an 8-inch telescope, it's taking the amount of light that's falling on a mirror this big and focusing it down to something like this. So the intensity of that light coming out is hundreds of times greater than the sun is just looking at it. Now you can't, it's actually fairly difficult to do major damage to your eye just by looking up at the sun. I don't recommend it. It's a bad idea. It can burn little tiny spots in your retina. Those usually can heal. It's hard to completely go totally and permanently blind by looking at the sun. If you look through binoculars, it's easy. If you look through a telescope, it's inevitable.
Yeah.
So don't do that.
Fractions of a second. Do not do this. And people say, oh, I'm going to look through mylar from a balloon. Not necessarily safe. It could have a pinhole in it. People say, I'm going to look through multiple layers of X-ray material that have been overlapped. Again, not necessarily safe. The only thing that you can use safely is solar glasses that say "for the sun" on them. Exactly like those.
Like what I'm wearing now. They're chic and sexy.
And you should have just enough time to order them if you haven't yet. They're available via Rainbow Symphony and a whole variety of other places. I know NASA got theirs from Rainbow Symphony this year.
I got mine from Astronomers Without Borders.
Right. They're a great. They're only taking large minimum orders at this point.
Yeah, I'd order 10. I've given most of them away. You can call around to camera shops if you're lucky enough to live in a big city that has telescope shops, like LA, New York, that kind of place. Sometimes they'll have them. You can just buy them. I know that Fisk Planetarium here in Boulder, Colorado, was selling them for $2 each. I think they're out. But you know, if you happen to live in Boulder and you're listening to this, but you can call your local planetarium, call your local observatory, talk to. I have links on my blog again today to places where you can find a local astronomy club.
Yeah.
My advice is don't look at the sun with your unaided eye.
No.
Don't use sunglasses, normal sunglasses.
No.
Only use, like Pamela said, only use things rated specifically for looking at the sun. If you do, I'll point out that Venus is just a hair under 1 arc minute across. And 1 arc minute is about the resolution of the human eye. So when something looks to be, an arc minute is just a measure of how big something is on the sky. And so the human eye is roughly an arc minute, 2 things separated by an arc minute. You just barely see them as 2 things. Or a circle that's bigger than an arc minute looks like a disk. So if you have particularly sharp eyesight, and you know, the right protection, you can actually see Venus as a disk. In 2004, I had these kind of glasses, and I was able to run outside for like 1 minute. I was doing about 1 billion 5-minute local news things from NASA, talking about the Venus transit and how we're going to launch the Kepler telescope someday, and it'll use this technique, and we'll talk about that in a minute. But I was able to see Venus as a disk. Now, if you have binoculars, if you have a telescope, you know, with binoculars, if you want to do projection, where you point them at the sun without looking through them and project them on a piece of paper, I do that all the time. You may be risking your optics doing that. I have these binoculars here behind me are nice, but they didn't cost me that much money, so if I melt the eyepiece, I'll be sad but not devastated. So I use those a lot, and I'll probably try that during the transit. Since the sun is setting, I've got a window right here that faces west. Hopefully I'll be able to project the transit live while we're sitting here next week. So I also, let me just put it this way. If you don't know what you're doing, if you have a telescope or binoculars, if you don't know what you're doing, do not look through the eyepiece. There are filters you can buy that fit over the top or whatever. If you're not an amateur astronomer with some experience with this, I wouldn't recommend doing it. A much better idea is to find a local astronomy club if you want to see this thing for yourself, because they will probably be having star parties for this. Or, say, watch our live webcast, because we'll have big telescopes around the planet to be able to see this live.
And then there's just other cheap, free, silly, but completely functional ways of safely projecting the sun. This is one of the ones that we talked about during the solar eclipse, where you take a mirror and you cover it in foil, you make a small circle cut out of the foil, and then you project the reflected light onto a board, and this acts just like a pinhole camera. So this is a cheap way you can get engaged with your kids in completely covering a mirror. You can get a nice clear view that you can make as big as contrast allows. And if you make a bunch of mirrors, you'll end up with a bunch of images.
Right. Now, one thing you need to be aware of is you have to hold the paper usually farther away from the mirror than you think.
Yeah.
Like 10 or 15 feet.
Yeah.
We did it, golly, with an eclipse when I was in grad school. It was a long time ago. But we had a big mirror, and they cut a big hole out of it to make the image bright, and we projected it into a building with a flat mirror and then up to a ceiling, and the sun was this big. And you could
wow.
See it was really slick, actually. And we got a really nice image out of that, actually. So, I'm not going to guarantee that'll work for this transit. I just don't know. Venus is small compared to the sun, but
practice.
It's worth a shot.
So one of my plans is I'm probably actually tomorrow going to be setting a bunch of this equipment up, making sure it works in my driveway, trying it out. Practice ahead of time. If you have good weather, go outside, destroy things in the name of looking at the sun. And start also, one of the interesting things that came out of the solar eclipse is people noticed places where the leaves cast funky shadows. This is going to be another one of those times where not quite as cool as with a solar eclipse, but where you can use just those pinholes to be able to project and see the sun. Now, one of the off things that can happen, and it has happened with both of the Mercury transits I've seen, is we may end up with sunspots bigger than Venus. So don't expect this to be a huge ordeal. The sunspots are about the same size as Venus is going to appear.
Yeah, I'm looking for what the sun looks like now, and I believe I want the intensity gram. There we go. Yeah, there are a few spots on the sun, knowing which way the sun rotates. I'm looking at a live image from Solar Dynamics Observatory. If you just type SDO into Google, it'll take you right to the site, and there's a picture that says, "The Sun Now," and you can choose a bunch of options. And if you look under HMI intensity gram, I love that, it's basically an image of the sun that you're used to. And I see a handful of sunspots. In a week, they'll be on the edge of the sun, and I have no idea what will be coming around the eastern edge at that point. But it's entirely possible we'll have ginormous sunspots on the sun. But what's funny is through a telescope we're projecting them, they're not as dark as Venus. For some reason, Venus just looks darker. I was shocked at what Venus looked like in 2004. It was a pitch black disk on the sun. It was very cool.
Yeah, it really was. I unfortunately only got to see other people's images of it. I traveled all the way up to Nova Scotia where I saw nothing. We got to watch baby eagles with their molted feathers doing silly things in the Bay of Fundy, which was quite awesome. I highly recommend going to see the Bay of Fundy.
Was it cloudy?
It was raining on us. We had golf umbrellas over our telescopes in hopes that we'd get a brief break in the weather. But here's, for those of you who haven't gotten to it, here's a quick view of the solar image that Phil was talking about. And the way you get to this is you just go to sdo.gsfc.nasa.gov, and it's this drop-down right here that will get you to the intensigram.
Yeah, it's kind of a funny phrase, intensity gram, which is what any photograph is. It's just a measurement of light intensity, but it's NASA. They got to call it something special, or else people won't spend millions of dollars to fund their missions.
We need to find a sentence where you use that word and ambiguify in the same sentence.
Yeah, I love jargon, but I try to explain it if I can. One thing we haven't covered yet, actually, is why historically this is an interesting event. these days, today, this sort of event is how we detect planets orbiting other stars. The Kepler mission, which is orbiting the Earth, actually looks at a spot in the sky, and it's looking at 100,000 stars, and it's looking for a little dip in their brightness. If a planet orbits a star and they just happen to line up, if you have a star, right, yellow tennis ball like a star, and a planet, and the planet's orbiting the star, if it orbits like this, the planet never blocks the star. But if it orbits like this, and we see it like that, then for a while it blocks the star. And so you're blocking starlight, star gets dimmer, and you can see that. Well, that's what this transit is doing. So today, in modern times, I mean next week, there are plans of observing the moon using Hubble. And what they're going to look for is to see, since the moon is lit up by the sun, and Venus is going to block 0.1% of the sun, the intensity of the moon should drop by 0.1%. They're going to look for that. They can also look for, they're going to try to detect Venus's atmosphere, which is awesome. And I kind of know how they're going to do it, and I'm glad I'm not on that project, because that's going to be a nightmare to reduce that data. But more power to them. I think it's an awesome thing they're doing. But historically, the first transit was actually seen in the 1600s, and it was quickly understood that this could be used to determine the size of the solar system. Now, what Kepler did, when was Kepler, the 1500s? 1600s? I can never remember. I can't keep these guys straight. Hundreds and hundreds of years ago, Johannes Kepler figured out the distances to the other planets in terms of the Earth's orbit. So if you think the Earth is 1 unit from the sun, we'll call it an astronomical unit. Then Venus is 0.7 astronomical units, and Jupiter is 5 astronomical units away. But that doesn't tell you really how big the solar system is, because you don't know how far the Earth is from the sun. And they realized, hey, the transit of Venus can tell us this. And how you do that is, as Venus passes in front of the sun, if you're looking at it, if I'm looking at it, say, from this angle over here, right? How do I do this? If I'm looking at it from one angle, I will see the transit happen at a different time than if I'm looking at it from a different angle. So if I'm looking on one side of the Earth at the transit versus the other time, they'll see the transit starting at different times. And you can use that to knowing how big the Earth is, which they knew even hundreds of years ago, you can use that to calculate directly how far away Venus is. And that tells you at that point how far away the Earth is from the sun and how big everything in the solar system is. And it turns out it's really hard to do.
Well, and the corrections required, because you also have to take into account that if you're north versus south, where it crosses on the sun changes.
Yes.
How long it takes to go across that larger, smaller distance changes.
Yes.
And then there's the whole problem of, well, getting your watches aligned.
Yeah, and that was a real problem, was actually clocks in the day. I mean, you're talking about timing measurements all across the Earth 300 years ago, 200 years ago or more. And so having accurate clocks was critically important. And and the other thing is the black drop effect, it turns out, makes it very difficult to get an exact time of the transit. And it turns out they were able to get the distance, and I'd have to look up the times. Wikipedia actually has a really good article about this. Go to Transit of Venus on Wikipedia. I was really happy with how well researched it was. I actually have a couple of books on the bookshelf here about the transit from the last one, and I was checking the Wikipedia and everything. The entry's good. But they were able to get the distance to Venus to like within 3% or something like that. Then in the 1882 transit, they were able to get it even better. And now it doesn't matter, because we can bounce radar off of the other planets, we can send space probes to these other planets, and we know to frightening accuracy how far the Earth is from the sun. I think to within 30 meters we know where the center of the Earth is. So yeah, we don't need to get a whole lot better than that, so we're okay. So now the transit is just something interesting. And
well, you know, actually, there is one neat new piece of science that they're going to try and get out of this.
Okay.
Do you know what they're doing with the Hubble Space Telescope?
Well, looking at the moon, that's what I was talking about earlier.
Right. So they're actually that is essentially new science. So
yeah, it's refining the technique that Kepler is using. The cool thing about this is, you know, we're looking at these other stars, and we're just seeing them as points of light. And we don't know how big the planet is, but there are methods of sort of, we observe the star and we know what kind of star it is, and we have models that tell us how big that star is. And we look at the planet, and when it transits, we see the dip in the starlight, and that tells us how big the planet is. But we're basing this all on models. We're pretty sure these models are accurate to some number. Yeah, I'll make something up, 1%. But you always want to be better.
Yeah.
So when observing the Venus transit, we know how big Venus is. We know how big the sun is. We know what Venus's atmosphere does. So we eliminate a lot of the unknowns in that equation. So by looking at the moon and seeing how the light from the moon changes, we can hopefully take that back into these models of extrasolar planets and be able to refine those even better and get better sizes for these planets.
And what's nice is the moon is just 1 day past full, so we have this nice bright illuminated surface to be using. We couldn't get luckier in a lot of ways. There's actually a partial lunar eclipse the day before the transit, so the sky is just throwing things out at us left and right. We had the solar eclipse just about a week ago. Now we have lunar eclipse, Venus transit. All the nodes have lined up.
You know, I'm glad you said that, because I was thinking about this observation. When I was working on Hubble, we were trying to do something similar. We were going to look at the moon and try to see the reflected light of Earth on the moon. When you look at the crescent moon, right out when it's new, you see sort of that thin crescent, and then the dark part of the moon, you can see it sometimes. Yeah. That's not an illusion. That is being illuminated by the Earth. The sunlight's hitting the Earth and reflecting off the Earth and hitting the moon and lighting it up. And we were thinking that by looking at that reflected light, we might be able to determine some things about Earth's atmosphere and do some stuff with it, and using Hubble. And I thought it was kind of a fun idea. It didn't get accepted. We never did it. But I was curious, because one of the things we were thinking about is when you look at the moon, if you're looking at a place where there's a shadow going across, like you're looking at a mountain, say, and you see that mountain in your image, and there's a shadow, that shadow is changing length very slowly as the sun is rising on the moon. It takes a lot longer than it does here on Earth. The sun is up for 2 weeks. But we're looking about, for the transit, we're talking about a change in sunlight of 0.1%. It's a very tiny change. And that shadow moving over a rock, or if it dips into a valley or something, that could easily be 0.1%. So I was curious as to how they would account for that. But since this is a day after the moon is full, the sun is shining straight down on the moon, shadow lengths will be very small, so that effect is minimized. So that's pretty cool. I'm glad you said that, because I hadn't thought of that.
And the field of view for the Hubble isn't all that large, so it's possible to find an area that's well away from any of the shadows.
You just look on a plane. You're still going to have crater rims and stuff like that, but they're using a space telescope imaging spectrograph, so they can use a slit and make it very narrow, and it has resolution down to a few hundred meters on the moon, so it's pretty amazing.
So it's going to be exciting next Tuesday, and we give you guys the potential to spend way too many hours with us. I know I'm going to have my cooler here ready to go, and we hope that all of you out there will join us. I'm not seeing a lot of questions out in the comment thread, but I'm going to invite questions, and I know Phil needs to get going, and I need to get blogging to get all of you the information you need for this event. While I'm looking for questions, just a public service announcement, I guess, or a station announcement. This is the weekly Science Hour produced by CosmoQuest. I'm Dr. Pamela Gay of Southern Illinois University, Edwardsville, and co-host of Astronomy Cast. With me this week discussing the Venus transit is the bad astronomer himself, Dr. Phil Plait. And you want to give a shout out for your URLs?
Yeah, you can find me online at Bad Astronomy. If you just look that up, you'll find me. I'm on Twitter as Bad Astronomer. I'm on G+, Google+. Also want to say ScienceGetaways.com is a science vacation package a company I've started is doing, where we'll be having a 4-day, 5-night, I may have that wrong, but it's something like that, in September, a dude ranch in the Rocky Mountains, where we're going to have astronomy, geology, and biology. It's like a dude ranch with science added. It's a lot of fun. So go to sciencegetaways.com and you'll get info on that.
It's something that I'm really hoping I can find in September. September is gone, too many plants. But it's something I'm really hoping I can do in the future. The combination of horses plus astronomy kind of has me pleased.
Yeah.
So I'm not seeing any questions coming in.
Really?
No, we have a good audience. There's about 60 people out there watching right now, but they seem to be a quiet 60 people, and we seem to be answering their questions without them having to ask them, which is working.
Oh, there you go. Hey, I see Richard Saunders is in here. Hey, Richard, old friend.
We're going to need to get him on this show.
Let's see, he's in Sydney.
Yeah.
Will he be able to see the eclipse, the transit?
Yes, and the awesome thing about Australia is if you not only do they see the whole thing, but if you look at a map of typical weather for this particular day of the year, Fairbanks is looking like 15% clear, Anchorage is looking like 10% clear, Australia 90% clear, especially in the northern parts. So we're hopefully going to have nice clear spring skies here, but it could also be tornado season on Monday. So we'll wait and see, or on Tuesday. We'll wait and see what we get.
Come to Boulder. We have 300 and something clear days a year.
And then 6 feet of snow now and then.
Actually, we do have a question from Eddie Ledbetter, who's asking, what's the best place online to find out how to build a device to view the transit?
Venustransit.org has some great links, and so does GalileoScope.org.
Oh, I didn't know Galileoscope does. I'll look that up and add that. My blog post, I have links as well. My blog post was up this morning. Do you see any other questions? That's the only one I saw.
Yeah, I'm not seeing anything else. Well, it's been, wait, here we go. Just occurred to me, light pollution isn't an issue for this sort of observing. That's a comment from Citizen Gold. No, that's the awesome thing about this is Manhattan city skies, you actually get a double show because you have the Venus transit occurring just at sunset, and this time of year is when a lot of the sunsets appear straight down the major east-west roads in New York City. So you have the chance of potentially seeing this fairly nicely lined between skyscrapers.
Yeah, Manhattan Henge, they call it.
Yeah.
Yeah, if you live in Beijing, light pollution might be a problem. It's
more haze. Yeah. Beijing.
That filters out the sunlight, so.
But the Beijing Planetarium is a fabulous facility if you ever get a chance to go out there.
Oh, that's right. You were in China.
Yeah. So, the Communicating Astronomy to the Public meeting. So this has been great. I'm sure we'll have you on again in the future. And for those of you who are willing to listen to Phil and I and Fraser Cain blather on more, we invite you to join us next Tuesday for all event coverage of the Venus Transit. This has been Dr. Pamela Gay of Southern Illinois University, Edwardsville, brought to you by CosmoQuest. Our next hangout is going to be tomorrow, and I believe Phil and I may both be there as well. Are you going to be on the Space Hangout now?
No, I'm afraid I can't. I'm traveling to Space Fest in New York City and then coming back and doing the transit, so I am overloaded right now. So
tomorrow is without Phil going to be the weekly Space Hangout, and I'm actually not sure if I'm going to be there yet either, but I think Noisy Astronomer is going to be Nicole Galucci, Dr. Nicole Galucci, also of CosmoQuest, and here at Southern Illinois University, Edwardsville. Hosted by Fraser Cain, the weekly Space Hangout brings you a roundup of all that's new in astronomy. Hop on, join us. It's at 10 a.m. Pacific, 1 p.m. Eastern, and then Sunday night we will have our weekly virtual star party, and then Tuesday's the lead event. So stay tuned and watch the blogs for all that's new and great. And thank you again, Dr. Phil Plait. Find him by Googling Bad Astronomer and circle him on Google+. Thank you very much, Phil.
Thanks, Pamela. See y'all.